So hello guys, this is Cybernaut. Welcome to another video, and today we'll be solving another Leetcode Daily. And today's question is a medium question, which is a good question indeed. So I will be reading the question first, and this question has many approaches, one of which I was able to solve, and that was passing in login solution, and other two are the solution one I get from this only the solution section, this only code NCT. So shout out to him or her. I will mention the solution link in the description also, like the explanation is too good, intuition is also good. This is the most upvoted solution of today. And another one is partial sum, which I get the intuition from the Aryan Bhaiya's video, but the concept was also taught in another video of Algozenith, which was taught by our Vivek Gupta sir. Okay, so I will be solving today's question and tell you guys all the three approaches here. Okay, so let's get to today's video. Okay, so you are given a zero indexed array nums and a non-negative integer k. In one operation you can do the following: choose an index, then that hasn't been chosen before, and range, select a range. Okay, so you can operate this operation from range 0 to n minus 1 and replace the nums of I with an integer from range nums of I minus k to nums of I plus k. So basically for each number you will have in range from nums of I minus k to nums of I plus k, that you will have to find out, and you can change the number from to any integer from between those two range, and return the maximum possible beauty of the array nums after applying the operation. So what is the beauty? The definition of the beauty is given here. The beauty of the array is length of the longest subsequence consisting of equal elements. So you have to make as much as elements of the array equal. You can as much as elements of the array you can make equal. Okay, so as you know, the subsequence doesn't have any order like substring or subsegment. Okay, so you have to do the maximum number of equal elements in the array. That is the beauty of the problem, that is the beauty of the question. You have to find the maximum beauty. So in the first example, it is given 4 6 1 2 and the k is given as 2. So what we can see here, first of all, as it is not a substring, you can easily sort it. Keep it in mind. So like it is a big intuition, you can sort the array or sort the string. Yeah, sort the array. So here in this example we can apply the following operation on index 1, that is this 6, and the range becomes from 6 minus 2, which is 4, and 6 plus 2, which is 8. So you can select 4 from the range, and in index 3, that is 2, you can select 4, as the upper range is 4 and lower range is 0. Okay, now what you have to do is select as much as number as same. So for this you can have 4 4 and 4, so 1 will be excluded, and you can easily say that your answer as 3, because the three number of elements having same that are same is 3. Okay, so how can you do this? I will show you the brute approach, the naive approach, which is nothing but n square. We go up to n square. I will show you the intuition. So let's take one example. Okay, so I will go through the code only and you will easily get that. I will show you the first example of is this in this code, and you will get the thorough intuition. Okay, so what it is, I have declared a map here, and I am iterating from 0 to n, and another iterator is from the range minus k to plus k for each and every element, minus k to plus k, and you are doing the sum basically, and you are increasing the frequency of the number, and after doing so you can easily check the map, and your answer will be basically the maximum frequency one. It is basically like this. For first example in the question, I will take the first example from here, 4612 and k equals to 2. Okay, so I will take the first example here, 4612, where k equals to 2. Good. So what you can do for here, your pointer, that is I pointer, will move from 0 to n minus 1, and your another pointer, which is j, it will move from minus k to plus k. So for this case, minus 2. Oh, this pen is so much inefficient in Windows. I don't know why. Like, I use Linux in general, but oof, this XP pen works totally fine in Linux, but in Windows I don't know what problem it is facing. So yeah, so the inner loop will run from -2 to +2. Okay, you can see here also, it is more iterating from minus k to plus k, and for each of them you can simply -1 0 +1, you can simply do the addition with your nums of I. You can simply do the addition of nums of I and do the frequency. Okay, so for this it will be like, for +2, what it can become, 5 6, and for this in the lower range, for lower range it will become 3 and 2. For this it will be upper as high as 8, and for this it will be 5 4. For this it will be 0 -1. For upper it will be 1, not 1 2. It would be 2 3. For this it would be 1 0, and for upper range it would be as high as 4. So after that you can see the 4 is present in 3 times, here, here, and here. So the answer is 4. So the answer can be 4, and the nums of I can be 4, and your answer can be 3, as the frequency is 3. But there is another solution also for this 3. Here you can also find 3. No, in this, there it is not 3. Here it is 3, and here it is 3. Okay, so your answer can be at max, and at optimal can be 3 only. Okay, so that hence you are returning 3. And what will be the time complexity here? The time complexity will nothing but n into k, and k can be as high as your 10 to the power 5, so basically n square. And your space complexity can be as high as n square. So it is the brute extreme naive approach. I will show you the better approach that I was be able to solve in the question. This is something like range maintaining. I will show you the intuition, and it is a good technique to solve these range problems. So for each and every element, you first sort the array. Okay, as it is a subsequence, I already told before, you can easily do the solve operation here, as it is not a substring. Okay, so for this I will show you then. Let's say take the same example only. Okay, so what it was given, it was given array, it was given 4612. 4612. After sorting it would become, 1 2 4 6. So now what we can do is, we can do something like a range. For this, what can be the range? It can be a range of -1, okay, -1 and 3. Yes, so it have a 2 range, lower range and upper range. For each and each and every number, you have two ranges, minus k, nums of I minus k, and nums of I plus k. So it is it. After that I will be iterating to 2. Okay, so after getting to 2, I will do something like, what can be the range updation. If you want to update the range and take both of them, what can be the updated range of both of them? Like for your left, it can be max of both of them. Think like this element have ranges of its own, but the both of them will will their ranges will be updated. Like I will write the range of 2 first. A range of 2 can be what? Nums of I minus k, which can be 0, and nums of I plus k, which can be 4. But their combined range can be, okay, their combined range can be max of both of, the L of both of them. Okay, I will show you why. 0, that would be, and for upper range it would be mean of both of them, which is nothing but 3. Okay, so 0 and 3. So why 0 and 3? So if you think, if you like, this is a popular technique also, a range updation. If you are in 1, like if your answer contains 1, if your subsequence contains 1, your range can be -1, 1, that is 1 minus k, and 1 plus k. But if you have 1 and 2, what your left range can be? Your left range can be the maximum of the one, the rightmost one, that the maximum one, the maximum lower of 2 basically here. So lower of 2 is what? 0. And what your maximum range can be? That maximum range can be the minimum of the all upper ranges basically. So it is here 3 and 4. Just do a dry run in your head, or in do it with pen and paper. You will get the answer. Okay, you will get the intuition. And I will now show you for when the index will reach the 4. I will show it also here. Like for this, when it will reach in 4, what will be the range? Your range will be from, it will update again. For 4 you have 2 and 6. So your combined range will become CR. I'm just telling in short. CR will become the maximum of both 2. The left range will become 2, and your right range will become 3. So it is, till now it is also valid, 2 and 3. Okay, but whenever comes the 6, its sole range is 4 to 8. And if you update this to maximum of this 4 and minimum of this, which is 3, you can notice one thing, which is left is greater than right. And whenever you are facing this, you will simply say ki you cannot add the rightmost one. Okay, so this is the intuition of this problem. Like in the code I will show you. At first you have sorted the array, then here I am taking the left as nums of 0 minus k and right as nums of 0 plus k at the initial, and I have declared the answer as 1, because 1 is the basic answer, right? Even if you cannot make the entire array as same, a single element can be a subsequence. So that is why the answer is 1 here. Okay, and the size is also 1. Size is like I will calculating and do the maximum operation every time I will get answer. Now that thing I was mentioning, I will update the thing. Left equals to max of L comma minus nums of I minus k, and right equals to minimum of right comma nums of I plus k. And if your as I told here, nums of L greater than R, size will format to 1. Okay, size will format to 1. Now what you can do, like when you are facing something 6, what you can do a binary search. Why binary search? You can say that your entire array is sorted, your entire array here is sorted, so you can do a binary search to find your most feasible or most you can say the number of elements you can remove from the left side, number of elements you can remove from the left side, so that you can get a new fresh sequence or new fresh segment which is valid. Okay, so that is what I am doing here also. I am selecting a low as 0 and high as 0, and if the index x minus 1, the basically the index up till our left can go. It is like a sliding window, but it is not, but it is just a manual search. And if your I is greater than 0, I will update to I minus 1, basically the range of, like, if here you are facing this problem, like you cannot add this, so you have calculated this part, right, the maximum till this part. Like if the array was too much big, you can go on and go on, then you have calculated till this part, you have calculated this part, so you can do something like you will include this and exclude the elements which are not affecting or not what say not fulfilling the criteria, like L greater than R. So this is the thing I have also written in the binary search also. So your low is 0 and high is index minus 1, basically the index before the point that are facing problem, and I am calculating mid. So if nums of mid plus k greater than L, basically the point till the right is greater than equals to k. Basically if it is this part here, this part is nothing but your R of the mid element in the binary search, and if it is if it is if it is doing something not greater than L is not more greater than R, then you can simply update your mid index and search for, or search for more size, like you can increase the size, and if it is not, simply do the search for higher index. And if your index is not minus 1, that means you have find index from which you can take the subsequent size. You will simply update your size to I minus index I, which is your current index, minus your index at at that index from where you can remove all the elements from the left side of the index, so that you can have a valid subsequence. Great. So you have updated the size, and you can now update your left and right too. Left will nothing but max of L comma nums of int minus x int minus k, and R will nothing but minimum of R comma nums of int plus k, as I have already calculated this after getting a break, this after getting a break. Okay, now if it is not, like if it is not facing any issue, simply do the size plus plus, and after each and every iteration, answer will greater than like the maximum of answer and size is the size which we are maintaining, and after then return the answer. It will work fine. And what would be the time complexity? The time complexity will nothing but n log n for the sorting, and for this solution also n, and if you are doing the binary search, it will be log n, so your time complexity will nothing but n log n. Okay, and space complexity, there is nothing thing we are using for solving this problem, so the space complexity will be big of 1. Okay, now the good approach I was talking about, I will mention this solution also in the description. This is a totally intuitive solution, and this code, you can see this code is too much big, but this code is like only 5 to 6 lines, which is why you should always look at other solution also. Like first solve the problem, and if if you have done, then also check other people solution from discussion, and if you have not, then you have to check other people solution. So this solution was good, I will say. And how it is solved. So what is the intuition? So if you see, I'll show you here. This is the first example after sorting. In this you have to sort. Okay, so after sorting 4612, you will get 1246, and their corresponding ranges are here also. This -1 3 0 4 2 6 4 8. So one thing you can notice, this answer are feasible or can be good, like this three, or these three can be good, as I have mentioned earlier in the brute force. Like here it can become 3 3 3, and here it can become 4 4 4. So one thing can you notice, key from this 1 and 6, the difference is what? Difference is, or get the gap is basically 5, which is greater than 2 into k, like which is greater than 4. So whenever you will iterate the array, approach is simple. You will iterate the array, and whenever you will say the gap is increasing than your 2 into k between two numbers, you will adjust the window and you will calculate the maximum till you are getting valid subsequence. This is the problem. This is the solution, and I think this is totally intuitive. Like you can check here for any other uh, elements also. Like you can check 1 to 2, the difference is 1, which is less than equals to 2 into 2, which is the k. Okay, and if you check for this also, 6 minus 2, the difference is 4, and you can easily check it is 4 is less than equals to 2 into k. Okay, so the code is also totally fine, like the basic code for sliding window. You are sorting the array, then you are declaring the answer as 1, and the left, there is a left index which will be started as 0, and our right will go from 0 to n plus plus. And whenever you will see you are facing problem like nums of r minus nums of l, basically the right index element and left index element, right index element will be always greater as it is a sorted array. Okay, so if it is greater than 2 into k, you will simply do the l plus plus, and you will calculate the answer, which will be nothing but r minus l plus 1, right minus left plus 1, and you will simply return the answer. This is a good solution, I would say, good solution. And your time complexity will be in n log n for sorting, and for sliding window it will be big of n. Space complexity is also big of 1 here. Okay, so this was the second approach, and the final approach is also a good one. Okay, so now we will be moving towards our last approach, which is partial sum, and this will solve the problem in big of n time complexity. Okay, so you can see in the code also, I will go through the code at first, like in the basic manner, then I will show you the example dry run, and then I will return to the code again. Okay, so first of all, we are not sorting in this one, so hence the n log n complexity which we are taking in the sorting part is boiling down. And then we are declaring a partial sum array, and that size is 2 into 10 to the power 5 plus 1. I will also tell why it is. Then we are iterating the nums array, and for each nums array we are declaring a range, left range and right range. Okay, so here left range, which is nums of I minus k, and right range, which is nums of I plus k, and updating our this partial sum, like this is a generic trick you can find also. I will mention the video link. In YouTube it is present, I guess. Like it was taught by Vivek Gupta sir in Algorithm channel. I will mention the video link in the description. you can check it. Okay, so if like for each and every L and R, we are updating +1 and -1. Okay, and then we are performing the partial sum, and for each of answer we are basically doing the max operation of partial sum of I and then returning the answer. I will tell. So this the intuition is more based on the brute approach, which is nothing but doing iterating the nums array and iterating from -k to +k. Like for each and number we are calculating their frequency. So the intuition is kind of like that. So I will tell here what I have done here. So what I have done here is for 1 2 3 4 1 2 4 6, it is the array in sorted order. Okay, so you don't have to sort it also, but like you can say 2 4 6 1, like the order that was present. So sorting is not important here. Okay, so what the laser pointer goes, here it is. So for 2 your range is from 0 to 4. Okay, so it is the number line, let's say. So 0 to 4, it is the range of your number 2, and all of their frequency will be added +1. So if this is 1, all of this will be +1. And for 4, your range will be nothing but -2, -k basically, terms of I minus k, which is 2. So that becomes 2 plus 2, which is 6. So your range will be from -2 to 6 here. So can you conclude one thing from here? If I do something like this, for each and every left range, like for 2 the left range is 0. If we do +1, and after finishing the range, like which is right +1, R for 2, R is 4, R +1, we can put a -1 here. Basically what we are doing in the code here, partial sum of L +1 plus equals to 1, and partial sum of R +1 minus equals to 1. Okay, and this part, which is L less than 0, I will show you why it is doing so. Like for example, the range of 1 is from -1 to 3. So what you can do for -1? For -1, we are not going to -1, right? Like we don't need the frequency of -1. The negative elements are not needed, because you are not doing the negative stuff, like you are not calculating that. Okay, so you can put a simple 0, nums of 0 plus 1 plus equals to 1. So that will add up till your right range. So what I have done here is basically that if L is then equals to 0, less than 0, partial sum of 0 plus equals to 1. Okay, and then we will simply do the addition here, +1 +1 +1, and after your calculation of the range, you will simply put a -1 in the outside, like one side extra of your range, which is nothing but R +1. So you will update your R +1 with -1. Okay, after that you will go through the entire partial sum of size, and you will calculate the partial sum, and your answer will be maximum of the frequencies. Okay, clear? So why the size is 1e5 plus 1, 2 into 1e5 plus 1? It is nothing but it is nothing but your constraints, which is for 6. Let's say for 6, what can be your range? What can be the maximum number you can store? 6 plus k. Okay, 6 plus k. So the maximum element constraint is here given, which is nothing but nums of I can be 10 to the power 5. Okay, so that is your 10 to the power 5 plus 10 to the power 5, which is 2 into 10 to the power 5, and plus 1 you can take always for extra, so that you are not going out of range. Okay, so these are all the three approaches, and I think the entire solution is clear to all of you guys. So yeah, this is it. This is today's video. And if you guys have any queries, you can ask in the comment section. If you are wanting to ask any queries, you can do that in LinkedIn, Instagram. I will definitely reply. And yeah, that's it for today's video. Until then, keep grinding. See ya.